So, the purpose of an API is to connect different software applications and let them talk to each other. Straightforward, right? You open a weather app on your phone, and it instantly shows you the forecast. The exciting part is how accurate that prediction is. How did meteorologists use complex algorithms to forecast the weather? But let's rewind a bit. Was it really that simple for your app to get the weather data? Let's have a look at how API connections work. From your local coffee shop tracking its daily sales to global corporations managing millions of customer interactions, data is the lifeblood of a modern business. Weather monitoring stations store data from their sensors, and service providers might store their customer's address or date of birth. All these organizations collecting information carefully store it in databases so they can use it when they need it. A database works like a classic filing cabinet. If you want to be able to find the information you're storing there, you need a good system of labels and categories to make retrieval quick and accurate. In a digital filing cabinet, instead of drawers and folders, you've got tables and fields, using column names and data types to categorize the information. Each table is for storing a specific set of information, called a dataset, and the fields in that table hold individual pieces of information, called data points. When you log into an app, it sends a query to its database with your user ID to find the right pieces of data for your account. Your profile photo appears, your name is displayed, and actions you take in the app are saved to your own account. This is how all applications work, on your phone or on the web. There's a user interface for you to interact with, and what it's really doing is either retrieving some data to show you or taking your inputs to create new data. But what happens when your app needs to show data that's stored in someone else's database? For example, a news channel or weather app needs to monitor real-time data being created at weather monitoring stations all over the world. Or, a business needs their e-commerce platform connected to their financial software, so their books are always balanced. The first problem you'll run into when trying to send and receive data with another app's database is that system of labels and categories we talked about earlier. Each database has its own labels for the data it holds, and if you don't know what the fields are called, you won't get the data you need. The second big problem is security. You don't want to share your database with just anyone, and the people who do have access shouldn't be able to get other people's personal data. You need to control who can access your database and whether they can make changes to the data in there. The third issue arises when too many people start making requests to your database. It will slow down or crash. You need a traffic control system to keep requests and responses flowing as smoothly as possible without letting traffic get backed up. This is where an application programming interface, or API, comes in. It solves all three of these problems. You might have heard people compare an API to a waiter in a restaurant, taking your order and bringing you the data you need. But it's really more like a super-fast librarian. When you ask an API for data, first you need to authenticate, usually with an API key. Like scanning your library card, this tells the librarian what you're allowed access to, and they can process your request. If you don't have a valid library card, you'll have to come back once you've got one. After your credentials, you write down your request. This is where it's important to know what to ask for. Since each database has its own field labels, developers create API documentation. This is like a dictionary of label names and terms the API can understand. Other developers use this dictionary to learn how to structure their API requests. API docs also tell developers what the API is capable of. You might want to integrate data from your email campaign tool into your marketing dashboards, and a developer will need to review your email campaign tool's API documentation to see what fields can be retrieved. At a functional level, APIs work with a simple request and response cycle. Each time you send an API call, you'll get a response. That response might come back with an error code if you aren't authorized, or if you didn't use the right labels for the fields you requested. If your request is authorized and written correctly, the API will respond with the data you asked for. When you open your weather app, it sends a request to the Weather Services API. This request will be written in code, but essentially says something like, "What's the current temperature in New York City?" The API receives this request, processes it, retrieves the necessary data from its database, and quickly sends back a response with the requested information. Remember the request-response cycle? If you're monitoring data in real time, that cycle has to repeat constantly, maybe even several times per second, to keep the data fresh. This is where the traffic control system comes into play. Applications with public APIs need to process thousands to millions of requests per second. Developers use a number of strategies to do this without clogging up or crashing the system. The first is to set a rate limit for how many requests you can make in a certain amount of time. An API gateway acts like a valve, controlling the volume of data that can flow to and from the database at any given moment. The other main strategy is to use separate databases for different kinds of information, dedicating more resources to the things people send more frequent requests for. These individual resources can be accessed separately by using a specific URL in the request, called an API endpoint. Developers set different rate limits for each endpoint, so they can dedicate more traffic to the data that's in high demand. For example, you might be able to send thousands of requests per second to validate a list of email addresses, but only one request at a time to check the status of a specific email campaign. So there are different endpoints to connect to when you're requesting different types of data from an API. How do you know where to send each request? You guessed it. The developers put that all in the API documentation. There's a lot more that goes into properly optimizing an API. If you're building your own public API to share data from your database, your API strategy should involve caching, pagination, and perhaps even a backend for frontend to optimize API usage. But we'll stick to the basic concepts for this explanation. In less than 10 minutes, we've covered the basic purpose, function, and anatomy of API connections. Understanding this fundamental piece of digital architecture can be a major game changer for what you can accomplish. In summary, APIs are like librarians, traffic lights, and security guards rolled into one. Using API documentation, you can decipher exactly how to interact with an API to put data in the right place at the right time. Key business reports can be automated, multiple tools can be integrated into one system, and marketing messages can be personalized for each customer. The possibilities are truly endless. From getting real-time weather updates to posting a comment on this video, APIs are putting in the behind-the-scenes work to keep us all connected. What would you build with a custom API connection? Let us know in the comments below. Are you looking to develop a custom API or set up API integrations? Our team can help. At KSense, we specialize in building business operations software. Visit ksensetech.com to schedule a free consultation with an expert and see how custom API solutions can take your business to the next level. If you enjoyed this video, please like and subscribe. Let us know what you'd like to learn more about next.